Hello everyone, today I want to show you how we can solve this differential equation up here. So the first thing you will notice is that we have a second order derivative, and that may make it look a little difficult, but it's actually not difficult because you can reduce this using a very simple substitution. Let's say we're gonna use the dummy variable, I like the letter v, so let's use v. Let v be equal to y prime, okay? And then notice that if we do this, we're going to be able to write a first order linear differential equation with respect to v. So y double prime then, that would be, I'm just going to say v prime would be equal to y double prime. And that means that we now have the differential equation v prime plus v is equal to 4x, okay? And I hope that you can notice that you can solve this using an integrating factor. And you can use this method very simply because we don't even have a p of x function, so it should be very simple. So yeah, let's use the method of the integrating factor to find v, and then with v we can integrate that expression to get y, okay? Because if we integrate v, we're gonna get back y because v is equal to y prime, okay? Remember. So let's do it. So I'm gonna multiply both sides of the equation by an integrating factor, let's say r. So we're gonna have r times v prime plus r times v is equal to 4r times x, okay? R is going to be our integrating factor, and it will satisfy the following condition. R will be a function such that this is true. R times v will be equal to 4r times x, okay? Remember, if you've never seen this method of the integrating factor before, this may seem like I just pulled it out of thin air, but there is actually a good reason to do it, and you're going to see it in a moment. First of all, notice that 4rx is equal to the right-hand side of our equation, so we can set this equal to these two terms. And I'm going to rewrite this using the product rule. So this will be dr dx times v plus r times dv dx. And that's going to be equal to these two guys, which will be r v prime plus r times v. Okay, now notice r dv dx and r v prime are the same, so those two will cancel out, and we're going to have dr dx times v is equal to r times v. We have v's on both sides of the equation, so then we get something really nice in the end. We get dr dx is equal to r. Okay, and r is going to be our integrating factor, and we can find it by solving this separable differential equation. So we can do the following. We can say the antiderivative of dr over r is going to be equal to the antiderivative of dx, okay? And that's going to give us ln of the absolute value of r is equal to x plus c, meaning that r, we can exponentiate both sides of the equation, and we're going to have a constant. Typically, we let this constant be 0. So if you exponentiate 0, well, that's going to give you 1. We can let this constant be anything that fits our needs, and anything that simplifies our calculations. In this case, letting c equal to 0 is the best decision. So if we let c equal to 0, then if we exponentiate that, well, that's just going to be 1. And so we have e to the x. That's our integrating factor, okay? Now, going back to this, why do we want to make this equation true? If you've never seen this method before, this like you should be concerned about this, but there's a really good reason why we make this. Notice that if you integrate both sides of the equation with respect to x, you're going to get this. You're going to do d dx, so the antiderivative of d dx of r times v with respect to x should be equal to the antiderivative of the other side, which is 4rx dx, okay? This is what we have, right? Now, what do we have this? Here, we're integrating with respect to x, the derivative of this quantity with respect to x. That is obviously just going to undo the derivative. So you're going to get back rv, and the same thing on the right-hand side, okay? Now, notice this. Notice that over here we almost have a formula for v. If you divide both sides of that equation by r, you're going to get 1 over r times the antiderivative of 4r times x dx, okay? And this is almost, well, not almost, it is a formula for v, okay? And v is what we're trying to solve for. So we make this we make this substitution because then we can do this. And then as long as we have r, that is why we were solving for r, as long as we have r, we're gonna be able to find v, okay? That is why we make this, in case you've never seen that before. So yeah, let's solve this integral. So we know what r is going to be, so this will be v is equal to 1 over e to the x times the antiderivative of x, well, there's a 4 here, I'm going to put the 4 here, check this out, this is very convenient, I'm going to pull the 4 out of here, yeah, that should be fine. So I'm going to pull the 4 out, the 4 that comes from this integrand, and this is going to be x times r, which is e to the x dx, okay? Now we can solve this integral using integration by parts, I believe. So then let's see what we can do here. So remember that integration by parts goes, the antiderivative of uv prime is going to be equal to uv minus the antiderivative of u prime v. And ideally when you use this technique, you want to make it so that u prime vanishes. You want that to become a factor of 1, and then you're just integrating v. Now based on this, I think that if we let u be equal to x, when we differentiate it, we're only going to be integrating v, and v just happens to be e to the x. So yeah, let's do that. So let's do let u be equal to x, and let v prime be equal to e to the x. Okay. So then we have the antiderivative of x e to the x dx is going to be uv, so that's going to be x times v, that's going to be e to the x. Remember, the antiderivative of this is the same, minus the antiderivative of, so u prime is going to be 1, so that vanishes, and then v is going to be e to the x. So this is awesome because we get e to the x dx, okay? And this means that, well, our integral will become, I think I can do it here, yeah. Our integral will become x e to the x minus e to the x, okay? So this is our integral. We can check what do we get. 1, if we differentiate this, yeah, we would get minus e to the x and then a product rule here. That's going to be 1 times e to the x minus x times e to the x, and that should, the e to the x's cancel, and you get this back. Yeah, this should be right. Nice. So then let's plug it back into this equation. So we have, and something, well, yeah, something, hopefully you caught this. There's a plus c here, okay? And that plus c is going to be really important. This is probably one of the biggest pitfalls that people encounter when using the method of the integrated factor, so be careful. And I say that because remember that we're multiplying this entire thing, like we're multiplying 4 divided by e to the x by this entire integral, including the constant of integration. So we're multiplying this times x e to the x minus e to the x plus c, okay? And in this case, when we do something to this c, it will not absorb the multiplication or the division that you're doing to it, because we have e to the x in the bottom. So this will actually become, so let's see. So we're gonna have these two e to the x's cancel. So we have 4x. This one and this one will also cancel, so we have minus 4. And finally we have 4 times c, that operation will absorb the multiplication into another constant c. So I'm going to use again c, but now we're going to divide by e to the x, okay? And this is where a lot of people make the mistake of saying, oh, this is just a constant. If I multiply by this, that's just going to give me another constant. Nope, it's going to give you a constant in the numerator, but e to the x will still remain in the denominator, so you get this in the end. And now that we have this, that would be the final answer. And well, not really a final answer, that would be the final answer for v, okay? But remember, we made the substitution v equals y prime. So really, we can say that dy dx, which is v, dy dx is equal to 4x plus some constant c divided by e to the x minus 4, okay? If you integrate this, then you're gonna get the function for y, okay? So now that's our next step. So we know that y is going to be the antiderivative of this entire thing. So it's going to be 4x plus c divided by e to the x minus 4, and this entire thing integrated with respect to x, okay? So I'm going to continue up here. I believe I can finish this problem in this space. Yeah, I think so. So let me just do this. Just going to create some separation here so that we don't mess things up. Cool. So if we integrate this, that's going to be, I'm going to do it here. Y is equal to 2 times x squared. That's going to be the antiderivative of this term. Now this one we may have to do u substitution unless you can figure out inside your head what's going to happen. But this term first, which is easier, it's going to be minus 4x. And now the antiderivative of this, you could try doing it in your head. And really what you're doing here is saying, well, let's say we have e to a negative x. If we differentiate that, we're just going to get e to a negative x times a negative. In e to the negative x times a negative, and you want to get rid of that negative because this is positive. So you're just going to have minus, then you're going to have minus e to a negative x, because if you differentiate that, you get back this, okay? If you can do it in your head, perfect. If you can't, you could use a u substitution and let u be equal to e to a negative x. But here, well, I'm going to do it, yeah, just to be what, mathematically clean, let's say, e to a negative x. And then something you do is, yeah, e equals negative x, du is equal to minus dx, and then you would just get the integral of c, e to the u, a minus comes out in front, du, okay? And you're gonna get what I was saying before. This will be minus c e to the u, and we know u is negative x, so overall we're just gonna get e to the negative, oh well, not negative, if I'm putting it down here, we don't need the negative. So this becomes e to the x, okay? That is the mathematical representation of what I just said before. And overall we get our final answer. So it should be 2x squared minus 4x minus some constant c e to the x, okay? If you differentiate this twice, that should be equal to 4x, okay? And let's check if that's true. And hopefully you cut this before me, because I know if I don't do this, I'm going to be flamed in the comments. Remember, this is C1, and because we integrated a second time, we get a C2 here, okay? Be careful with that. Your math teacher may mark you wrong if you don't put the C2, okay? So watch out. But yeah, let's differentiate this twice. So if we do y prime, we're going to get, this is 4x minus 4. And then if we differentiate that, so that is the derivative of e to a negative x, that should be plus c1 over e to the negative x times e to a negative x, which should be c1 over e to the x. That should be right, yeah. And then let's differentiate this again. So if we do y double prime, this should be 4 plus, and now the derivative of this, that will become minus c e to the x, okay? And let me fix this there we go. And now let's add them up and see what happens. So if you add these two guys up, well, you can see what we're gonna get already, and that is going to be right. 4x plus 4 minus 4, and then plus c1, and I missed that 1 here, plus c1 divided by e to the x minus c1 divided by e to the x, and we know this is equal to y double prime plus y prime, and we are claiming that this should be equal to 4x, and obviously it is equal to 4x. You can see these two 4's cancel out, and so do these two terms here, and we get 4x in the end. So our answer is correct, okay? This is a really cool problem because you have what appears to be a complicated differential equation, but in the end it works out really nicely, and you should have no problem solving this and getting a final answer for y. So yeah, I hope you enjoyed this video. I hope you learned something. I hope you were able to see how to use the method of the integrating factor and how to, make this substitution. and I hope to see you in my following video. Bye.